Hello, everybody. Welcome to my talk. It's about PHP value objects and you. My name's Daniel Leech. I'm going to see if my clicker works. And it doesn't, of course, because I haven't plugged it in. So let's do that. OK. There we go. Now I'm going to start my stopwatch so that I don't talk too long. So my name's Daniel Leech. I am self-employed. Like many of you, I make software and help deliver software projects for money. And I've been programming for about, not quite 20 years, but it's coming on 20 years, mainly in PHP. And I maintain a couple of open source projects. One of them is PHP Bench, which is a tool for measuring performance. And it's used by a lot of open source projects in the PHP ecosystem. And the other one is Factor, which I wrote because I wanted autocomplete in Vim. Does anyone use Factor? Wow, that's surprising, and I'm really sorry about that. And I've also got a lot of abandoned projects, and some of them are good, some of them are not so good. But yeah, I have spent a lot of time, a lot of my free time programming. So this talk is based on a blog post that I wrote last November, and it's about PHP, and this is a PHP conference, so that's fine. And it's about you, because you use PHP, I guess, and it's about value objects. And I'm giving this talk because I've been in discussions where people are discussing value objects, and they think they're a good idea, and they're right. And they've heard them, and they want to use them, but they're discussing, what interfaces they need to implement. Like what packages do they need from Packagist in order to use value objects? Like where should we put the value objects? And I'm sort of scratching my head, because I use them all the time. Like I use them in the project that you're discussing. You don't need interfaces, you don't need packages, you don't need anything. They're just a tool in your toolbox. It's a bit like we've all heard of the project manager that won't let you write tests because the client's not paying you to write tests, right? But if I'm in a project, I'm going to write tests because it's going to make me deliver the software quicker, right? It's not going to slow me down, it's going to speed me up. And it's the same with value. They're just a tool that you have in your toolbox, right? You don't need permission to use them. And they're part of what I like to call modeling, right? So you've probably heard of domain-driven design. And modeling is, I'd say, a part of that. And it's about describing your problems and representing your problems in code. So I like to think about this as, you've got a sculpture, maybe it's Michelangelo, right? And he's got this block of marble. And he's looking at this thing, and he's thinking, what's inside this block of marble? And he starts chipping away, and he tries to discover what is in the marble. And he's chipping away at it, and he's chipping away progressively, and he's figuring out what's inside. And at the end of the day, it's a cat, I think. And I think solving problems with programming is very similar to this. You get a problem, it's a Jira ticket, something like that. And at the beginning, you don't know much about it. You don't know where the boundaries are. You don't know the details. You don't know the edge cases. You don't know the algorithm. But by progressively chipping away at this problem, you can define it. You can define a specification of this problem in your code with a model, with object-oriented programming. And so in that toolbox, you might have many tools. You've got adapters in hexagonal architecture. You've got entities, collections, interfaces, factories. And you've got value objects. And I think value objects are one of my favorite tools. and one of the most useful. So what are value objects? So obviously, value objects are objects that represent a value, but we know that. But what's a value? So values are things that have no identity other than themselves. So 7 is a value. 8 is a different value. You can't update the value of 7, right? If you change it to 8, it's a different value. An IP address, 7 is a scalar value. An IP address has 4 numbers. If you change any one of those numbers, it's a different IP address, it's a different identity. The identity of a value object is like the sum of its parts. You can't change any individual element of that value object without changing its identity, right? If you contrast that with an order in an e-commerce system, you can change all these things about the order, but it's still the same order, it's still got the same order number. Value objects, they represent an identity. And this is what one looks like. So this is a very simple value. It's the simplest value object you can get, and I wouldn't recommend that you create value objects to represent integers, right? And it's not even the best value object you could create, but this is all it is. This is a value object. It represents a value. And we can look at if you were to look at my code, if you look at some of my source code in Factor, you might see some value objects. So this is a date. It's not a date time. And you might be asking, well, why would you create an object to represent a date if you've got the date time object? And it comes back to this idea of modeling. Like if we're carving away at our little marble block, and we're chipping away with the chisel, defining, and then we get the date time. We just plonk it there, and we knock off the nose of the cat, right? It's too much. Like the date time, it has too much information. What we're missing here is the context. There might be a timesheet application, and you don't need these nanoseconds. You don't need a time zone database. You don't need all these additional things, all these superfluous things to the problem that you're trying to solve. So we just create something that represents an aspect of the problem we're trying to solve. In this case, a date. You might also see money. So money doesn't exist as, you don't get 10 monies or 20 monies. It doesn't exist as an independent value. So you always need a currency code to associate with an amount of money. And these two values, these two properties are bound together. One doesn't make sense without the other. A geolocation, right? A point on the planet Earth, and a color. All of these are unambiguously value objects. Like, there's no doubt. But what about this? This is an address. So the first one, we can look at those two addresses. We said that's the same address. The second one's got a spelling mistake. Is it a value object? And yeah, I'm kind of like, maybe it is, maybe it's not. It's definitely not as clear-cut as those things. But at the end of the day, it shouldn't matter, right? So sometimes we should solve problems in terms of the problems themselves, right? If you need an address, create one. If you can pick some things from this idea of value objects and put them into this address, that's fine. You need to solve your problem first. You need to define your problem first. And the terminology is not important, right? Terminology and these tools are just those. They're just tools that help you to model your problems. So is this a value object? So it's not. It's an entity. And what's an entity? So you are an entity, right? You get out of bed, you're feeling yourself, you put on some clothes, you eat your breakfast, you dye your hair, you change your state, right? You change things about yourself, but you're still the same person. The same with this e-commerce order. When it's placed, it's in this state, pending. Then the customer places the order, it's placed, and then later on it's shipped. everything about this order can change. You can add items, you can remove items, you can change the state, but the order number stays the same. It's still the same order. And this is an entity, right? You can change all the other properties, but it's still the same thing. And a value object, if you change any of the properties, it's a different value. So that's what a value object is, but what patterns can we use with value objects? So the first one is immutability. Some of the things I was saying in this talk are kind of optional. You can use them, not use them, depending on the context. But immutability, I think you should always use immutability with value objects. There's no doubt in my mind. Because you can't change 7 to 8. You can't change. Who's used like date time in PHP? And I know you all have, right? If you're PHP developers. Who's had bugs with date time? Yeah, a lot of people. Didn't expect that many people to put their hands. Yeah, because date time is a mutable object. So if you add a day to it, and it will be added in all the different places that date time is referenced. And it's frequently not what you want. It's an easy way to introduce bugs, which is why we introduced, why PHP introduced the datetime immutable. I'm sure if it was done again, it would have been immutable by default. Like making datetime mutable was probably a mistake. So always make them immutable. You can't change 7 to 8. You can't change a value. You can't update the value of a value. It doesn't make any sense. The value is an identity. The next really important thing is that value objects are responsible for ensuring their own validity. And this is done in the constructor. So if we have a color, we have red, green, and blue, those values must be between 0 and 255, and if they're not, throw an exception. The main point is if you can instantiate a value object, it's valid. If you can't, it's not. And the beautiful thing is if you're writing code and you see you've got a value object, you don't have to worry about if it's valid or not valid. You just got this thing. It's a color, it's an IP address, it's whatever it is. And you don't need to worry about ensuring the validity of that object because that responsibility is with the value object itself. So we're putting all of these behaviors and all these things into the value object. They don't need to be external to it. A lot of my value objects are statically constructed. So we have static constructors. So why would we do that? We could just say new color, RGB, which sometimes that might be okay. But why would we want to use a static constructor? So basically, there's more than one way to create a lot of value objects. There's lots of representations that we use for value objects. So for a color, you could say from RGB, from HSV, from int, from hex. And if you're using new color, you don't get that. If you use an auto-completion, you say color from, and all of a sudden you've got all of the different options. You can see, you can explore the ways you can represent this color, that you can create this color just from your auto-completion. That's useful. But the main point here is that if we use, can I use the pointer? There we go. If we use new color, you're exposing the internals of the value object. So later on, you might want to not represent the internal state with red, green, and blue. You might want to represent it internally as hex or as an integer or something else. By using static constructors, we abstract that away. We protect the internal state of our value object, which is important if you need to refactor your code, right? You don't have to. You can freely refactor the internals of your value object without worrying about refactoring anything else. You're protecting that state. Sorry, I think I've... Yeah. Press the wrong button. There we go. And you can go from, but you can also go to. So this is a way of converting from between values. So the value itself is this kind of abstract thing. It doesn't know, it's not an RGB color, it's not HSV color, it's just a color. So we can go from RGB and we can go to RGB, but you can also go from RGB to hex. And we can use this as an intermediary between two representations as well. And so it's sometimes difficult to say where this is going to be useful. And the beauty about using value objects and these rich domain objects is they will present ways to optimize your code that you didn't expect. And we'll see that later. Values in values. So you've got value objects, but you can also have value objects with value objects in them. And this turns out to be very useful. So here we have a byte offset range. So in Factor, in the language server, I'm often dealing with text documents, which is source code. And I'll need to edit the source code in some way, so I'll use a byte offset range, which says from this point in the source code until that point in the source code, edit it, delete it, replace it, something. So for that, I'm using a byte offset range, and I use 2 byte offsets. The byte offsets need to be positive integers, so they're validated as such. And the byte offset range, the first offset needs to be less than the second offset, right? So it validates that. It ensures that correctness. And you don't really write this sort of code. I'm using literal values here, but you only do that in presentations and tests. But in tests, you do write a lot of this sort of thing. And when you're using these value objects, you can kind of compress. So that is the same code as that. It's exactly as safe. So internally, it's just creating those 2 byte offsets, but it's less code. So it's just little optimizations you can do to make your code easier to write and easier to reason about. So smells, code smells. So I've only got one code smell for you today, and it's this thing with having these 2 parameters. So with these smells, these indicators, when you're looking at your source code, you'll see things like this, and you'll think, I could use a value object here. And this is a very clear case of when you should use a value object. So you've got make payment, it returns a receipt, it takes an amount and a code. Now we're going to assume the amount is money and the code is a currency code. We don't know that. And of course, we use the money value object, and it looks better. It's an improvement. But why is this a problem? So it's a problem because amount and code can vary independently. So at some point, your program's going to get the amount and the code from the user, or from wherever it's coming from, and then the amount's going to be walking down this stack, and the code's going to be beside him. And you've got these 2 variables. They're going along, and it's all's going well, and then suddenly the code drops off the stack and is replaced with a different code. It was euros, and now it's USD. And the amount doesn't care. So it's just cruising on down. It's fine. And then it gets to this, and it's, someone's going to make or lose a lot of money because that amount became disassociated with the code it was meant to be against. By combining them in a value object, you lock them together. So when it comes into the system, it's just one object is one value. And you don't have 2 independent things walking down the stack together. You have one unit, one immutable unit, one value. So here's another example, a bit more extreme, but I've seen code like this. So we've got RGB1, we've got RGB2, we've got 2 colors represented as RGB and an amount. And this function will return the color at a point between 2 colors. So 0.5 will return the color, sort of halfway through that range. So obviously, use value object. It's a lot clearer now. This is, you made that change and it's a lot better. But we've carefully chipped off something from that marble block. and it's looking better, but we think, can we improve this? Like, how can we improve this? What's the relation between color 1 and color 2? It turns out they're a range. So we say we want the point between two colors. That's a color range. Okay, so we saw the byte offset range earlier. We can use that, and we've got a color range. Cool. So not a big one. We've removed one parameter, but it's looking better. But now the interesting thing is, how can we improve it further? We've got the method interpolate, which is operating on a color range, and it has an argument amount. And we've got this color utils class, right? Who's got a util class? Who's got a helper class? You know, I think we know that these are code smells. When we have these classes, we create them because we don't know what else to do, right? Our code needs to go somewhere, so let's create a utility class with lots of static methods on it. And here we're realizing that this interpolate method actually belongs on the color range. So we move it. So now we've got color range from colors, and we can say interpolate add, and it returns a new color. And in the code, it would look like this. And suddenly, we can remove this horrible utility class. We don't need it anymore, right? We've taken off an ugly bit of our model, and we've replaced it. You know, we've revealed something about the problem. We've identified that interpolate belongs to this color range. And the beautiful thing is, we didn't even want to do that when we started. We just started iteratively refactoring. We did one thing. We didn't think we'd end up with this. But it's just this process of one thing at a time, right? And this is modeling. As a counter, we've got, what's going on there? Center map. So of course we've got long lat. And is it long lat? Is it lat long? I'm sure people know. I don't. But it's an easy mistake to make. We can mix those up. So yeah, value object, of course. Okay, let's move center map to geolocation. Yeah, that doesn't work. Mainly because, yeah, centering a map has nothing to do with the geolocation. But the interesting thing here is that this function returns void. And void is one of my favorite return types. It's very informative. It means your function does one of two things. Either your function does nothing, or it has side effects. So when you have void, it usually means that your function is going to have side effects. It's going to save to the database. It's going to make a HTTP call. It's going to change a global variable. It's going to drop the database. It means it's got side effects, and you don't want side effects in value objects. You don't want hidden dependencies in value objects. So instead, you need to reverse that relationship, and you need to have a service that's going to accept the value object. You're passing the value object around. Not everything belongs in the value object. Only things that belong to the value, that relate to the value, belong in the value object. So I'll just get some water. So operators. So you're familiar with operators. So we've got integers, and you can do all sorts of operations on integers. So we've got addition, division. On strings, we've got concatenation with a dot. And with objects, we can use the equals. Right? We can say that one object is equal to another because PHP is going to compare the properties, the values of the properties of those objects. And most of the time, that will work fine with your value objects. But can we say that red is greater than red? Is red greater than green? Is green less than red? And you could argue that, yeah, somehow. Like, is it the brightness, maybe? Is it one brighter than the other? But it's not clear. It doesn't really mean anything, right? Can you multiply a color with another? And I don't know if there's any graphic designers in there. Maybe you can, but I don't know. But maybe that's not the terminology they use. So instead of using like PHP's built-in operators, I mean, these two don't work. Oh, what's going on there? Yeah, these two don't work anyways. We don't have operator overloading in PHP, right? Which is probably a good thing. So instead of that, we can implement our own operators, our own method calls. So we can say the red equals to red, okay? But then we can say red is brighter than light red. So we can start incorporating the terminology of the domain in our operators. You know, this means something. Red greater than light red doesn't really, yeah, it's just, in what aspect is it greater? And we can, you know, things like mix. We can mix red with green. This is an operation, it returns another color. And going back to equals, like most of the time equals is going to work, but some of the times it won't, because all operations are contextual to the value that you're operating on. So one example would be if we've got a set of tags on a blog post, and a set of tags. We've got PHP and programming on one blog post, and we've got programming on PHP on another blog post. Now, if you compare those tags against each other in PHP with equals, it's going to be false, because the order's different. But it's an unordered set, so all we need to know is that they have the same members. But the equals isn't going to help us there. When we implement our own equals to, we can take into account the context of the value, right? The value's got its own concept of equality. Another example would be drawing a line. So these have the same points, but if you render them in a different order, they draw different diagrams. So in that case, order is important, right? So operations are contextual. They depend on the value they're operating on. Okay, so bad practices, so things that I don't like. So one thing is bypassing the constructor. So how many people have done this? So you've said new self or new object, and then you've bypassed the constructor and you're assigning things to private properties. Like a few people. So when I discovered you could do this, I was amazed. I was like, oh, I'm going to use this for everything. This is great. And I was just getting into static constructors and all that sort of thing. And I didn't realize what a bad practice it was. So what's the problem with this? So one problem is you might forget to assign green. And every time you add a static constructor, you've got to do all this and all this. Maybe you assert it's valid, and maybe you don't. And this is one of the problems that frequently happens in software development, is when we have this bootstrap, this boilerplate that we have to repeat at scale. You know, we have to keep implementing this boilerplate over and over again. And each time we do that, that's a risk. And because developers are lazy, you know, it's a risk that actually increases. You're going to break your code. So what's the alternative to this? And the alternative should be obvious, and we use a private constructor. So all of the static constructors delegate to the private constructor. And this isn't just about value objects, it's about any object in PHP, right? Always instantiate your dependencies for your class through the constructor. Why? Well, for one thing, it defines very strictly its input parameters, right? These are not nullable, they're required. They've got types. You can't not set something that needs to be set. This is it's a definition. And you can validate in one place. So you're funneling all of those parameters, all those different representations, you're funneling them all through the same point of validation. So if you don't take anything else away from this talk, this is, always guard your objects against invalid state by putting everything through the constructor, right? That's the only way to create your object. No extends and no implements, so I've often seen like the value object interface, and I've seen it like, let's add a value object interfaces, add equals, then greater than, less than. And we've already seen that, a lot of these operations don't make sense, or at least they don't make sense in the context of the value. So applying these in a blanket way against all values isn't going to be very useful. So value objects are not an abstract type. And also, if you've got this interface and you add or somebody adds a new method to it, then people are going to be enforced to add these methods all over their code base. It's coupling all your value objects. There's coupling to this interface, right? And also, it doesn't make sense to compare two abstract value objects, like, is red greater than an IP address? Is a color less than a number or whatever? It doesn't make sense. Okay, so no value object namespace. So this is, maybe a bit more controversial, but this is more critique of how we tend to structure projects, especially greenfield projects, right? When we start a project, we look at the framework's documentation. It says, you put your entities in here, you form in there, your serializer there, and you end up with this flat list of object types. And the problem is that for the first feature, this works great, right? You just get in there, you create your controller, you create your entity, and it's very quick. And people love greenfield projects, but they're like this. They're easy to work with. You can do what you want. You're not always having to deal with all this legacy code. But then when we have to add the second feature, we're already in a position where we've got all these things from the first feature, and they're getting mixed together. Then the third feature, and the longer we go on, the harder the project is to maintain, the more legacy brownfield the project becomes. And so when we have this value object namespace, we end up with all these different value objects for different features, like license plates, invoice number, color. And even if you're comfortable with that, somebody's going to take one of those value objects and use it for something that it wasn't intended for. So what I prefer to do, and this isn't how you should do it, but I think structuring your project is one of the hard problems in programming, right? But the essence here is to structure your project by feature, right? So when you start a new feature, when you're implementing something new, it can be a greenfield project if you have a namespace for it, right? If you have a folder for it, like a green field in your estate. And then where do we put our value objects? Just put them there. Where do we put our collections? There. Where do we put our entities? Just put them there, right? As time goes on, you'll realize that there are categories of things, and you can put them into namespaces, and you can refine. And then this becomes your model, right? This folder is modeling your problem. And it takes away all the confusion about where things should go. So give yourself the space to solve your problems. I think it's one thing that I'm frequently confronted with when I join a legacy project. It's like, where do I put my code? There's nowhere in this code base where I could put my code. It's just a mess. Don't use a value object suffix. I think this is quite clear, right? It's the value. Would you rather talk about a color value object or a color? Of course, it's a value object. It's a value, right? It's not. It's like distance value object or distance. Just use distance. You can argue. I'm not against suffixes. I use them for some things like DTOs. But the value, they are the values. You don't need to qualify them any more than that. No serialization. So again, going back to this theme of like boilerplate repetition, I see this a lot. And if you're generating your code, then having to array and from array might make sense because you can make that reliable. But if every time you create a value object or an entity or a DTO, you're writing this code manually, we're lazy, we're going to miss things. And one of the most frequent bugs you'll encounter is like undefined key on array, missing array key. Or, a type error because the amount is a string and not an integer. So here I'm trying to validate all these things, but it's error prone. And also from array and to array. So to array should work with from array. So you should be able to go from and to and from and to. And you have to do that yourself. So the lesson here is not to try and solve serialization every time. It's one of these things, you do it once, you do it twice, you do it 3 times. You'll keep doing it, and you will make mistakes, and you'll make code that's brittle and hard to reason about. So use a serializer library, right? It's a hard problem, and they solve it. No mocking. So there are people that mock things, and there are people that don't mock things. I'm a person that doesn't mock things. I used to mock things, and then I had to maintain that 5 years later, and I spent about a week unmocking everything, and it was a lot easier to maintain from that point onwards. But there are people that say the mocking is good, and there's people that say the mocking is bad, but neither of those camps wants you to mock value objects, entities, DTOs, or data objects, basically. There's no point. They have no dependencies, and why would you mock the value 7? Right? It doesn't make any sense. You don't mock values, you use them. You create a value, you create a color, you create an IP address. You don't need to mock them. Okay. So, wrapping up. So value objects should be immutable. Thou shalt not change, but thou mayest spawn new versions of thyself. So what does this mean? So they're immutable, but they can spawn mutations. You can create mutations. So you can add 1 to 7, but it will return a new value, which is 8. Thou shalt be correct. Thou shalt not bear false representation. So they should always validate themselves. And if you receive a value object, you can have that confidence that it is correct. So this is like hugely reassuring, and it will simplify your code. It'll make your code easier to reason about. They should be isolated. So thou shalt not associate with false prophets. So ideally, you should be able to pick up a value object and take it from your Symfony project or your Laravel project and put it in a Drupal project. Just copy and paste it. It shouldn't have any dependencies. It doesn't have any dependencies because you're solving a concrete problem. You're not pulling in the framework, right, to solve this problem. You're not pulling in this and that. Like the frameworks have their use, and they serve a very important role. And that role is to get user input. And it's to send output to the user. Whether that input comes from a message queue or a HTTP request or a CLI command, it doesn't matter. The framework's job is to get data into your model and to facilitate the egress of the data back to the user. But that entire area where that input stops and where the output begins, everything there is your model, right? That's your code. It shouldn't be coupled to the framework.